What are they? The bright dense lights of the aurora are actually collision between electrical charged particles from the sun that enter the Earth's atmosphere. The lights are seen above the magnetic poles of the northern and southern hemisphere. They are known as aurora borealis in the north and aurora australis in the south. Aurora displays appear in many colors, although pale green and pink are the most common. Shades of red, yellow, green, blue, and violet have been reported. The lights appear in many forms, from patches or scattered clouds of lights to streamers, arcs, rippling curtains, or shooting rays that light up the sky with an airy glow. Colors. The colors seen on the auroras depend on the atomic or molecular species that the solar wind particles attract, and the level of energy those atoms or molecules reach. Oxygen is responsible for the primary colors on the auroras. Green and yellow are from a transition of energy at 557.9 nanometers. Meanwhile, red is produced by a less frequent transition at 630.0 nanometers. Human eye can appreciate the color beginning from violet, which in the spectrum it will have a wavelength of 390.0 nanometers, until it gets to the red to 550.0 nanometers. Nitrogen produces blue light. Meanwhile, helio is sometimes responsible for the red-purple coloration from the lowest borders of the auroras and the most curved external parts. What caused them? They are actually a result of collision between gaseous particles in the Earth's atmosphere, with charged particles released from the Sun's atmosphere. Variation in color are due to the type of gas particles that are colliding. The most common aurora color, a pale yellowish green, is produced by oxygen molecules located about 60 miles above the Earth. Rare all-red auroras are produced by high-altitude oxygen at heights of to 200 miles. Nitrogen produces blue or purplish red auroras. The connection between the northern lights and sunspot activity has been suspected since about the 1880s. Thanks to research conducted since the 1950s, we know that electrons and protons from the sun are blown towards the Earth on the solar wind. The temperature above the surface of the sun is millions of degrees Celsius. At this temperature, collision between gas molecules are frequent and explosive. Free electrons and protons are thrown from the sun's atmosphere by the rotation of the sun and escape through holes in the magnetic field. Blown towards the Earth by the solar wind, the charged particles are largely deflected by the Earth's magnetic field. However, the Earth's magnetic field is weaker at either pole, and therefore some particles enter the Earth's atmosphere and collide with gas particles. This collision emits light that we perceive as the dancing light of the north and the south. The lights of the aurora generally extend from 80 kilometers to as a height as 630 kilometers above the Earth's surface. Fun fact: these solar winds interfere with the communication system like TV, radios, satellites, electronic systems, and telephones. This natural phenomena isn't restricted to the Earth. Other planets like Jupiter or Saturn show these analogous phenomena that possess magnetic fields stronger than the Earth. Uranus, Neptune, and Mercury also have magnetic fields, and both possess wide radiation belts. When and where to see him? Mostly they are seen from September to October, and from March to April. Northern lights can be seen in the northern or southern hemisphere, in an irregular shaped oval centered over each magnetic pole. The lights are known as aurora borealis in the north and aurora australis in the south. Scientists have learned that in most instances, northern and southern auroras are mirrors-like images that occur at the same time, with similar shapes and colors. Because these phenomena occur near the magnetic poles, northern lights have seen as far south as New Orleans in the western hemisphere, while similar locations in the east never experienced the mysterious lights. However, the best place to watch the lights in North America are in the northwestern parts of Canada, particularly in Yukon, Nunavut, Northwest Territories, and Alaska, Scotland, Norway, Sweden, Finland, or Russia. Auroral display can also be seen over the southern tips of Greenland and Iceland, the northern coast of Norway, and over the coastal waters north of Siberia. Southern auroras are not often seen as they are concentrated in a ring around Antarctica and the southern Indian Ocean. Areas that are not subject to light pollution are the best place to watch for the light. Areas in the north in smaller communities tends to be the best. Of an aurora is that during the night, the aurora starts with a shape of a long arc that extends along the horizon, mostly to the east-west direction. Near midnight, the arc starts incrementing its brightness. Then it starts forming waves along the arc, and also vertical structures that seems to be long and thin light ray. Suddenly, the sky is full of spirals, bands, and a bright lights trembling and moving along the horizon for even minutes. When the sunrise arrives, the process seems to calm, and only in a few parts of the skies it appears brilliant light until the morning arrives.
This is where the tale of the aurora starts, on the Sun, a star of average size among billions of other stars in our Milky Way. The Sun acts as an enormous power plant. The energy is created deep inside the core of the Sun. Here the temperature is over 14 million degrees, and the pressure so enormous that hydrogen atoms are squeezed together into another element, helium. This nuclear reaction releases energy. The light radiates outward from the core of the Sun. In the outer layers, the heat moves to the surface in huge eddies called convection cells. These electrical currents of charged gas create magnetic fields inside the Sun. In some places, strong magnetic fields push their way up through the surface. They slow down the eddies of hot gas. The surface cools, and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outwards. The magnetic field stretches and twists like a rubber band, and then the rubber band breaks. Several billion tons of plasma is hurled out from the Sun. This is called a solar storm. The solar storm can reach speeds over 8 million kilometers an hour. After 6 hours, it blows past the planet Mercury. the planet Venus. And after 18 hours, the solar storm reaches Earth. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel where the gas streams down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks, and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora.